let's now implement the get Fibonacci sequence method. So now again, you can see that in the return type, it's an integer array. So that means we have to create an array internally inside the method and return it. And the size of the array depends on the input parameter I. Okay, let's review. Let's see what a Fibonacci sequence is. It's already explained here. I assume already read the description. Let me summarize that very quickly. And we can make the assumption that the input I is larger than or equal to 0. It's not going to be negative, but what if it's 0? What if it's 1? What if it's 2? And etc. Okay? So now let's look at this explanation over here. So Fibonacci sequence itself can be infinite. So now the I over here is simply going to give us the first I elements in the Fibonacci sequence. When I is 0, that means we want to get the first 0. That's pretty much like getting the first 0 elements in an arithmetic sequence. That would just give us empty array. Similar idea. Okay, let's now just study the sequence very quickly. Okay, so now for Fibonacci sequence over here, is always the case. The first element is always 1. The second element is always 1. So these two are always fixed. So that means when you say, first of all, when you say get Fibonacci sequence, the 0th elements, in that case, it will just return empty array. Okay, rather than null array, empty array. Similar to when you say you want to get a 0th, the first 0 elements from the arithmetic sequence, it will just be empty array. And what about if I want to get the first elements of the Fibonacci sequence? It will just give me an array of size 1 of index 0, and it will just be 1, corresponding to the first element over here. So what about if I have over here get Fibonacci sequence 2? In that case, I will return an array of size 2. Okay, so with index 0 and 1, and then 1 and 1. So that corresponds to the first 2 elements. So it seems like 0, 1, and 2. So these are the 3 special cases for us. Okay? And now, what about the 5 over here? Okay, it will also return an array of size 5. Okay, that's what it will do, right? Corresponding to the size 1, 2, 3, 4, and 5. So 0, 1, 2, 3, and 4 being the indices, and 1 and 1. Okay, now how do we fill in this, and this? How do we do that? So here, let's see the rule. The rule is starting from the third elements over here. Starting from the third elements, so this element over here is going to be the summation of the previous 2 elements, because the first element that applies to this rule is going to be the third one. So it's guaranteed there must be at least 2 previous elements in the before that. Okay, so now that means for the blue one, it's going to be the summation of the 2 previous one. So that'll be 1 plus 1, that'll be 2. Okay, so now how do we know the next one? The next one, let me use a different color over here. So now how do we calculate this element over here? It's the 4th element in the Fibonacci sequence. So it's going to be the 2nd plus the 3rd. Okay, hopefully you see that. One more. What about over here? Let's say, how do we know the value for this position over here? So this is the 5th number in the Fibonacci sequence. So it's going to be the 3rd and 4th. The summation of the 2. So that'll be 2 plus 3. So that'll be 5. Okay, so now as an exercise for you, so what should be, so now we got 8, 13, and 21. So what will be the next one? So the next one is going to be the summation of the previous 2, which is going to be 13 plus 21. So which will be 34. Okay, that's how you calculate. Okay, hopefully you see the pattern over here. So now, that means for now, if I just want to run this, I already know 0 and 1. The first 2 elements are always fixed to be 1 and 1. Now so I can start from index 0 over here. I can start from that. And now how do I know, how do I fill in the contents for this one over here? The way to do it is by, let's say currently the loop counter is I. So what I should do is, I should really go to elements at position I minus 1. And also position I minus 2. Okay, go there and retrieve the elements, and then I will get just 2. And similarly, when I increment to go to the next iteration, I is pointing to here, and then our position I minus 1 will be here, position I minus 2 will be here. So 1 plus 2, I will get 3. And then when I increment I further to the last iteration over here, so now you can see at position I minus 1 will be here, and position I minus 2 will be here. So I got 3 plus 2, which will give me 5. Okay, that's how I calculate. That's how the loop should work. So now let's make it work in Java. Okay, hopefully you can see the illustration. Okay, so now if you go back there, let's see what we can do. Okay, so now what I will do is I will simply do, let's declare the sequence that we would like to return. Integer array sequence is assigned to new integer array of size I. Return the sequence. Okay, eventually. So now we know that the in the case where the Fibonacci the I is simply just equal to 0, we just return empty array. We don't even bother to initialize anything. Okay, so what I would say is if I is larger than or equal to 0, in that case I'll do something over here. Especially I know I got at least one element over there, so I can at least initialize the first element to be 1. That's what I can do. You can see that if this condition over here happens to be false, that means we'll bypass the body of the if branch over here, and then we just go to return exactly sequence being empty. Okay, so now we know that. Okay, now let's see over here. Now if we reach this point, that means I larger than 0 is reaching here, I is larger than or equal to 1, right? This is really equivalent to I is strictly larger than 0. I'm just playing with the relation a little bit. Okay, so now we know we got at least one element. So now, but it could be that in the case where I is equal to 0, we bypass the body of the if statements. Okay, so now we got another special case to do. So now it could be that I is exactly just equal to 1, right? In which case we just need to have an array of size 1 and only copy the first element of this Fibonacci sequence over here, right? In that case, we can simply say, in the case where I is equal to just 1, we should bypass the body of another if statements, which I'm gonna do now. So I can say if I is strictly larger than 1, which means we got at least 2 elements over there. So now when we can reach this point, reaching here, I is larger than or equal to 2, right? Which is equivalent to I is strictly larger than 1, right? I just want to show you more explicitly. So now in this case, I can also set sequence 1 to be 1. So now, up to now, I want you to run a little bit more some test cases with you, just over here. If I is equal to 0, that means 0 larger than 0 will be false, which means we bypass the entire thing, and then return sequence being empty array. So that's correct. In the case where I is equal to 1, that means we create an array of size 1 over here, and then 1 larger than 0 is true. So we set the first elements of the array to be 1, which is pretty much like this case over here. Okay? And then 1 larger than 1 would be false, which means we bypass everything over here. And then we simply return that particular array of size 1. Okay, like that. Okay, so now, what if this I is equal to 2, 3, or 4, or onwards? So in this case, I'm going to do the following. Okay, so now I would say for integer, we already got I over here, so I better not use I to clash with it. So I can use J. So I'm going to start with index 2 over here. So I would say integer J is assigned to 2. And then J is less than I, because I will be the size of the array. If you like, you can also say sequence.length if you like. Okay, that's also equivalent, but I'll just say I over here. And then J plus plus. Okay, over there, I'm going to say pretty much like this. As said before, for the loop counter, I'm going to calculate the summation of the previous 2 elements, -1 and -2, right? So what I would do is, I can say sequence of element J at position J is assigned to sequence at position j minus 1 plus sequence at position j minus 2, the two previous elements. That's what I would do. Okay? Okay, so now they'll be reaching here. Okay, let me give you another special case over here. So now, in the case where I is exactly equal to 2, which is this case over here, where I is equal to 2, what's going to happen? So now when I is equal to 2, you will see that since we initialize j to be 2, so 2 less than 2 would be false. That means we do not bother to actually go inside to this loop over here, and then we simply just return the array with the sequence at position 0 being 1 and the sequence at position 1 being 1, and then return the array directly without executing this. So it's just correct. Okay, we bypass the body of the loop. Okay, you can see that it's just running some special cases with you. Okay, that's exactly this case over here. Okay, over here. Okay, so now I think that'll be it. So now let's just test our code. Okay, let's go to utilities tester, and then that's what we have, get Fibonacci sequence over here. Okay, you can see that over here we are calling some helper method which I define over here for you. You can feel free to study that. It's not difficult. So that you can also refer to the lecture notes. We talk about given some integer array, how we can output its string representation starting from curly brackets and ending with curly brackets, and separated each element with comma. Okay, that's something I can leave to you. Again, it's a case study. Okay, let's go back to get Fibonacci sequence over here. So I just get different size for you, 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's have a quick look to see what we have. Let's execute a tester, and let's see what we get. So when we get Fibonacci sequence over here, you can see when I is equal to 0, so we got empty sequence. Okay, and then when I is equal to 1, we got an array of size 1, and then it was just 1. And when I is equal to 2, we got exactly 1, 1, right? You can see it's 1 and 1, 1, and also empty array. That's exactly what we said before. And now let's also see what about over here. Let's say 5. Okay, 5 over here, that's also what we got. We got 1, 1, 2, 3, 5. Right? 1, 1, 2, 3, 5. Okay, let's go a little bit further. If I got 7, you can see 1, 1, 2, 3, 5. You can see 8 over here is exactly equal to 3 plus 5. And 13 over here is exactly equal to 5 plus 8. So things just work. Okay, so now you can also try to compare how we did this get Fibonacci sequence method with the previous one we did, which is about get arithmetic sequence. You will see that the code structure is rather similar. So the bottom line is, whenever you're trying to program in this kind of program, you should really just draw yourself some diagrams and to see what the special cases are. In the case of Fibonacci sequence, it's like this. And in the case of the arithmetic sequence, it's like that, right? Think about those special cases and how to derive in general. That's how you solve this kind of problem.